Hi everyone, this is Professor Oaks, and in this video I am going to do, 25 problems that involve trigonometric identities in 25 minutes. So here's problem 1, and here's my timer. And so when I press start, I will start on the first problem and then keep on going until either all 25 problems are done or the time runs out. All right, so here we go. So the first one is simplify sine cubed t plus cosine cubed t all over the sine of t plus cosine of t. So here I see this is a sum of two perfect cubes. So we have a cubed plus b cubed, that is equal to a plus b times a squared, all right, minus ab plus b squared. So in this case, this will be the a is the sine of t and the b is cosine of t. So I have, let's see, this will be sine of t plus cosine of t, and then times, right, sine squared t minus sine t cosine of t plus cosine squared t. And then this original expression then is all over. All right, this will all be over sine of t plus cosine of t, and then sine of t plus cosine of t divides out. So then I have sine squared t minus sine t cosine of t plus cosine squared t, and sine squared t plus cosine squared t that's a Pythagorean identity, right? So that one is actually equal to 1. So this is 1 minus sine t cosine t. So done. That one is done. So here we go. Here's, cotangent squared t minus 4 over cotangent squared t minus cotangent t minus 6. So this numerator is a difference of squares, a squared minus b squared, right? That's a plus b, a minus b. So this numerator is, right, cotangent of t plus 2, cotangent of t minus 2. And then I see in the denominator, I can factor this into cotangent of t, cotangent of t. And here I have a minus 1 cotangent of t and a minus 6. So I'm going to factor this using a minus 3 and a plus 2. So therefore cotangent of t plus 2 divides out. So I have cotangent of t minus 2 all over cotangent of t minus 3. So that one simplified, all right? I could change it to sines and cosines if I wanted to, but the point was to simplify it, and it's all in terms of cotangent of t now. So I'm done. All right, here's 2 minus tangent t all over 2 cosecant t minus secant of t. Well, this one is a little bit trickier, but let's just rewrite in terms of sine and cosine. So tangent t is sine of t over cosine of t. And then cosecant of t is 1 over sine of t. And secant of t is 1 over cosine of t. All right, so now let's go ahead and find the common denominator in the numerator here. So this is cosine of t. So I'll write this is 2 over 1. So multiply by cosine of t, cosine of t. So numerator is now, right, 2 cosine of t minus sine of t. And then the denominator, the least common denominator is, if you look, sine of t, cosine of t. So I'll multiply by cosine of t here, sine of t here. So I have all over 2 cosine of t, all right, minus sine of t, all over, right, sine t, cosine of t. Then I'll multiply by the reciprocal here. So I have 2 cosine of t minus sine of t all over cosine of t times sine of t, cosine of t, all over 2 cosine of t minus sine of t. Then divide out 2 cosine of t minus sine of t, and cosine of t excuse me, divides out. So I'm left with sine of t. So that is that one. All right, that all end up being sine of t. So the next one I have a cosine of t, or sorry, cosecant of t plus 1 all over 1 over sine squared t plus the cosecant squared t. So I actually know that the 1 over sine squared t, that is actually the cosecant squared t, and then plus cosecant of t. Then I'll factor the cosecant of t out of the denominator, so it's cosecant of t times cosecant of t plus 1, and then cosecant of t plus 1 divides out, so I have 1 over cosecant of t, and that ends up being, well, that is just sine of t. So there is another one done. All right, number 5, 1 plus cosecant of t over 1 plus sine of t. So I'll rewrite the cosecant of t to just be 1 over sine of t, and then this is all over 1 plus sine of t. And then I'll rewrite this 1 as 1 over 1 and find the common denominator in this numerator of sine of t over sine of t. So then I have in the numerator sine of t plus 1 over sine of t all over this denominator still of 1 plus sine of t. And that is actually 1 plus sine of t over 1. Then I'll multiply by the reciprocal here. So I have sine of t plus 1 over sine of t times 1 over 1 plus sine of t, and then the sine of t's plus 1 divide out, so I have 1 over sine of t, and 1 over sine of t is cosecant t if I want to write it like that. All right, so that is, oh, there's another one, number 6. 1 plus tangent t over 1 plus cotangent t. Similar strategy to the last one, sines and cosines, so tangent t is sine of t over cosine of t, and cotangent t is cosine of t over sine of t. I'll rewrite the ones as 1 over 1 and find the common denominator in the numerator, which is cosine of t, and then the denominator is sine of t. So then I have in the numerator cosine of t plus sine of t all over cosine of t all over, all right, sine of t plus cosine of t all over sine of t. I'll multiply by the reciprocal. So I have cosine of t plus sine of t all over cosine of t times sine of t all over sine of t plus cosine of t, and then sine of t plus cosine of t divides out, so I'm left with sine of t all over cosine of t, and then I can rewrite that as tangent of t if I would like to. All right, there we go. All right, now here we are with verifying some identities. So I have cosine of t times secant of t equal 1. Well, secant of t is actually, well, what is that going to be? That is 1 over cosine of t. So then I see, does that equal 1? Well, cosine of t over cosine of t of 1. So, well, 1 does equal 1. So that one is verified. All right, number 8, tangent t times cotangent t, does that equal 1? All right, well, tangent t times cotangent t, all right, so that tangent t is sine of t over cosine of t, and cotangent t is cosine of t over sine of t, so sine of t's divide out, cosine of t's divide out, so I'm left with 1. So yes, that did equal 1. All right, let's verify this. Does sine of t times secant of t equals tangent of t? Well, secant of t is 1 over cosine of t, and then sine of t over cosine of t is tangent of t. So yes, that is equal to tangent of t. All right, let's verify this one. Sine of t times cotangent of t, does that equal cosine of t? Well, cotangent of t is, well, cosine of t over sine of t. All right, and so the sine of t's divide out, and this is indeed equal to cosine of t. All right, does the cosecant of t over the secant of t equal the cotangent of t? Well, excuse me, cosecant of t, that is, all right, that is, well, that's 1 over the sine of t, and secant of t is 1 over the cosine of t. Then I multiply by the reciprocal, so I have 1 over sine of t times cosine of t over 1, which is cosine of t over sine of t, which is indeed cotangent of t. So that one is verified. Let's try another one. Number 12, does cotangent t times secant t equals cosecant t? Well, cotangent t is cosine of t over sine of t, secant of t. Well, that is actually, believe it or not, this one is 1 over cosine of t. All right, and so now the cosine of t's divide out. So I'm left with 1 over sine of t, which is indeed cosecant of t. So that one is verified. All right, so let's verify. Does 1 plus cosine of 2t times 1 minus cosine of 2t equal sine squared 2t? Well, if I distribute right here, I have 1. It's a difference of 2 perfect squares, actually. A plus b, a minus b, right? So this is 1 minus cosine squared 2t. And then, well, by the Pythagorean identity, like sine squared t plus cosine squared t equals 1, this is indeed sine squared 2t. All right, so there you go. That one is verified. All right, let's try another one. Does the cosine squared 2t minus sine squared 2t equals 2 cosine squared 2t minus 1? Well, all right, let's see. Well, I know that cosine squared 2t minus, all right, well, sine squared 2t is 1 minus cosine squared 2t by the Pythagorean identity, the one I just showed before. Sine squared t plus cosine squared t minus, is equal to 1 is the same as saying that sine squared t is 1 minus cosine squared t. So then we'll distribute the 1 here. So I have cosine squared 2t minus 1 plus cosine squared 2t. Then combine the like terms. I have a 2 cosine squared 2t minus 1. So this one is verified. All right, let's try another one. Oh boy. We have cosine squared t times secant squared t minus 1. Does this equal sine squared t? Well, all right, so I am going to just change, well, you could change this to sines and cosines if you would like. So I'm just gonna do that since that's what I've been doing. So the secant squared of t is 1 over cosine squared t, and then that's minus 1. And then I'll distribute here. So I have, cosine squared t over cosine squared t minus cosine squared t. So that will be a 1 minus cosine squared t. So then using the Pythagorean identity here, sine squared t plus cosine squared t equals 1. If I subtract the cosine squared t from each side, that's the same as, is sine squared t. So therefore, this has been verified, all right? Let's try another one. Tangent t plus cotangent t, that quantity times tangent t, does that equal secant squared t? All right, sine of t over cosine of t is the tangent t. Cotangent t, that's cosine of t over sine of t. And then tangent t is sine of t over cosine of t. Then I will go ahead and distribute. So what I have here is sine of t times sine of t, sine squared t. Then I have cosine of t times cosine of t, cosine squared t. Then plus, all right, here I have cosine t, sine t, all over sine t, cosine t. So the sine t's and the cosine t's divide out. So that's sine squared t over cosine squared t plus 1, and then sine squared t over cosine squared t, that's actually tangent squared t plus 1. And then this is one of the Pythagorean identities, all right? So of course, right, that's one that you know, or hopefully should know, is equal to secant squared t. So that one is verified. Number 17, tangent t plus cotangent t times tangent t. Well, actually, that looks like the same one that I just had. So you know what? That is not good. So here, let me find a different one for us. So let's pause this. And let's see, so what should our replacement problem be? How about 1 plus cosine squared 3t over sine squared 3t equals 2 cosecant squared 3t minus 1. I think that one looks like a good replacement to me. So here we go. So let's look at the, well, it doesn't really matter which one that you look at here first, does it? Okay, so, oh boy, all right, so let's look at this. We know that sine squared t plus cosine squared t is equal to 1. So then sine squared t is 1 minus cosine squared t, all right? So then I'm going to rewrite this part. The numerator is still 1 plus cosine squared 3t, and the denominator will be 1 minus cosine squared of 3t. All right, now, oh, by the way, if I say anything strange, it might just be that it's the first way that I am thinking about this. But now that I think about this one, I that could take forever. So I'm going to revisit this. All right. So I'm going to rewrite this as, all right, 1 over sine squared 3t plus cosine squared 3t over sine squared 3t. And then 1 over sine squared 3t is actually, that will end up being cosecant squared 3t. And then cosine squared 3t over sine squared 3t is actually cotangent squared 3t. And then instead of using that Pythagorean identity to verify this one, I am actually going to use the Pythagorean identity of, let's see, 1 plus cotangent squared t is cosecant squared t, or cotangent squared t is cosecant squared t minus 1. So this is now cosecant squared 3t, and then plus, all right, cotangent squared 3t is cosecant squared 3t minus 1. Then I'll combine like terms. So this is now 2 cosecant squared 3t minus 1, which is now verified. All right, 2 cosecant squared 3t minus 1. All right, let's try another one. So number 18 here. All right, sine of t over 2 over cosecant of t over 2 plus cosine of t over 2 over secant of t over 2 equals 1. So sine of t over 2 over, all right, now cosecant of t over 2, that is, well, that's 1 over, all right, sine of t over 2. And then we have cosine of t over 2 over secant of t over 2, which is 1 over cosine of t over 2. And then I will go ahead and multiply by the reciprocal here. So I have sine of t over 2 times sine of t over 2 over 1 plus cosine of t over 2 times cosine of t over 2 over 1. So this is sine squared t over 2 plus cosine squared t over 2, which I know is a Pythagorean identity, which is equal to 1. So this one is verified. All right, let's look at number 19 here. 1 minus 2 sine squared of t over 2, is that equal to 2 cosine squared of t over 2? Well, all right, we'll go ahead and, well, all right, there's a couple of ways that you can do this one here. So, well, all right, well, sine squared t plus cosine squared t is equal to 1. So if I want to substitute something for sine squared t, then I know sine squared t is 1 minus cosine squared t. So this right here will be 1 minus, all right, 2 times 1 minus cosine squared of t over 2. Then distribute the negative 2, so we have 1 minus 2 plus 2 cosine squared t over 2, and then 1 minus 2 is negative 1, so negative 1 plus 2 cosine squared of t over 2, which is also, if I rewrite it, 2 cosine squared of t over 2 minus 1. So that one is verified. All right, 20. 1 plus sine of t times 1 minus sine of t. This is a difference of two perfect squares, a plus b, a minus b. So this is 1 minus sine squared t, and 1 minus sine squared t is actually cosine squared t. And so that is the same as 1 over secant squared t. So that one is verified. All right, 21. We have 1 minus sine squared t times 1 plus tangent squared t. Does that equal 1? So, well, all right. So 1 minus sine squared t, that is actually equal to, all right, using the Pythagorean identities again, cosine squared t. And then we have 1 plus tangent of t. So that is actually 1 plus sine squared t over cosine squared t equal 1. All right, does that equal 1 at least? And then we'll distribute the cosine squared t. So we have cosine squared t plus cosine squared t times sine squared t over cosine squared t. And the cosine squared t's divide out. So I have cosine squared t plus sine squared t. And that is the Pythagorean identity that is equal to 1. So that one is verified. All right, I have secant of t minus cosine of t. Does that equal tangent of t times sine of t? Well, secant of t is 1 over cosine of t and minus cosine of t. All right, and this one might be a little bit harder, so look carefully at what is going on here. So now I'll find a common denominator, all right, of cosine of t. So I'll multiply by cosine of t over cosine of t. So I have 1 minus cosine squared t over cosine of t. And then 1 minus cosine squared t is sine squared t over cosine of t. Then I can rewrite this as sine of t times sine of t over cosine of t. So if I have sine of t over cosine of t times sine of t, then sine of t over cosine of t is tangent of t. So tangent of t times sine of t, and that has been verified. All right, let's look at another one. Can we verify sine of t plus cosine of t over cosine of t? Does that equal 1 plus tangent of t? Well, all right, I'll use a strategy similar to, what was that? Number 17, I think. All right, so this will end up being sine of t over cosine of t plus cosine of t over cosine of t. Then sine of t over cosine of t is tangent of t. Cosine of t over cosine of t is 1. So I can rewrite it 1 plus tangent of t. And so this one has been verified. All right, let's look at the next one. We have cotangent t plus cosecant t times tangent t minus sine of t. Does that equal secant t minus cosine of t? All right, so, well, I'll just change this to sines and cosines. So we have cosine of t over sine of t plus 1 over sine of t times sine of t over cosine of t minus sine of t. Well, this is, if I look here, a common denominator already of sine of t. So I have cosine of t plus 1 all over sine of t. And then here, if I find a common denominator, all right, I multiply by 1, yeah, so this will be cosine of t over cosine of t, because that's 1. So I have, well, all right, sine of t minus sine t, cosine t all over cosine of t. All right, so this one might be, in my opinion, if you look at this one might be a little bit more difficult to do. But let's distribute here. all right, just to see what we have. So we have, let's see, cosine of t, sine of t, all right, minus cosine squared t, sine of t, plus sine of t, minus sine t, cosine t, all over sine t, cosine t. So sine t, cosine t is cancel. So then I'll split this into two fractions. So negative cosine squared t, sine t, all over sine t, cosine of t, plus sine of t over sine t, cosine of t. So I'll divide out a sine t and one of the cosine of t's and one of the sine t's. So I'm left with a negative cosine of t plus 1 over cosine of t. And then 1 over cosine of t is secant of t. And then I can reverse the order here and rewrite this as secant t minus cosine of t. So this one is verified. All right, last one in 19 seconds. All right, cotangent t plus tangent t. This is cosine of t over sine of t plus sine of t over cosine of t. And then I'll find a common denominator, cosine of t, cosine of t, sine t, sine t. Oh no. Well, I was so close. Unbelievable. Well, in either case, let's finish this one out anyway. So the denominator is now, all right, cosine of t, sine t, and the numerator is cosine squared t plus sine squared t. And so that is actually a Pythagorean identity of 1. So 1 over cosine of t, sine t, and then we have 1 over cosine of t times 1 over sine of t, and 1 over cosine of t is secant of t, and 1 over sine of t is cosecant of t, and then I can reverse the order. So I have cosecant t, secant t, and that one has been verified. So I was a few seconds short, but I still hope that you enjoyed this video and my effort to try to do 25 problems involving trigonometric identities in 25 minutes. I hope that you, again, will be motivated to do more types of problems like this yourself in the future. All right, thank you and have a great day.